Hello, welcome. All right, let's get started. Let me just fix my audio here. Okay. Welcome to Code with me. If you're here, let me know in the chat. Say hi, and we'll get started. So I've been doing this series on just USD in general. This is the NVIDIA Omniverse channel, and USD is one of our core technologies for NVIDIA Omniverse. And so I just wanted to share more information about USD, how to work with it, and everything that you'll learn today and through this series will be applicable to NVIDIA Omniverse, but also to lots of other applications and a growing list of applications that support USD, whether it's by import or export, or they natively support USD within their application. So today we're looking at how to create a material that will work for multiple renderers. This is something that comes up fairly often, and I see some developers having a rough time with it, but it doesn't need to be so difficult. So we'll look at it today, and it's actually fairly simple. So everything that I show today will be on this Omni Code With Me repository, so you can get the code there. And so let's get into it. So what we're going to be talking about is USD shade. So this is the USD shading schema and mostly USD shade material. And USD shade material has what is known as a render context. And if we look at, let's open up Omniverse just to look at something visual here. So a material is a prim with these output attributes, connections that are basically feeding out the surface data for the material, the displacement, and the volume, which would be these three here, right? And a material can also be considered a container, containing a node graph of shaders and that are all wired up together to its Omni surface and Omni preview surface of textures. All right, so we'll have two good examples to look at here. And if I open these within the graph editor, there we go. This one is a Uber shader, and it plugs into, it has these outputs that plug into MDL displacement, MDL surface, MDL volume. Okay. This would be the material prim. You can see here that it says type material. And then this one is a little bit more involved. We've got a few shaders here. We've got one, we've got some that read from, sample from textures. Then they plug in those results into this preview surface shader. And then it outputs, in this case, just the surface, but it could output as well displacement and volume if it wanted to. And so this doesn't say anything about MDL here. It just says surface volume and displacement. So if we look at these, let's do something interesting here. I don't know why I created a plane. A plane's not interesting at all. But a sphere is. All right, we got two spheres. And we'll apply the OmniSurface on the left, preview surface on the right. Come on. Did it take? Yeah, it took. All right. So this one, let's make it red. And this one is probably a poor choice because it's probably going to want, textures. But what I'll do is I'll disconnect to this one. So hopefully now I can manually set the color. And that looks pretty bad because of we have these other black textures that are plugged in here. So I'll just disconnect them too. And we probably want some reasonable values here. These actually look okay. Nothing stands out to me as fairly bad, but yeah, opacity, occlusion. Nope, we do want one for occlusion. Let's swap this out for non-texture. Funky boy. Come on, come on. Oh, crash. Sorry, folks. I'll try one more time. So what I wanted to show is, what I'm going to show is I'm going to have the two spheres. One has the MDL material, which is great for the RTX renders. And then the other one is going to have the preview surface material. And we're going to see what happens. And what I often hear from developers, what they observe. And this time I'll just create two. And then we'll pick this one and create OmniSurface. And then we'll pick this one. And create preview surface. Okay. Then this one we can make red. This one we can make green. Ooh, that's a nasty green. And looks wonderful in RTX real-time rendering, right? Looks great in interactive. It'll look great in iRay. But then we go to Pixar Storm, and granted the lighting changed. We won't mess with that. Mostly I could use a light that maybe is more compatible. Let me see what happened here. Doesn't support prim type distant light, right? So that's what's happening, is that Hydra doesn't support that light. I'm sorry, Storm doesn't support that light type. So let's do sphere light. Okay, and we'll do a couple of these. And everyone's happy. We'll get rid of the default light. So now, not great lighting, but a little bit more one-to-one, right? Except the MDL material, Storm doesn't know what to do with that shader definition. So, welcome Markham 3D and Eric Craft and Data Juggler. So what's going on? So what do we do? Like, I want to create content with these nice MDL materials that have all sorts of fancy stuff, but I also want to be able to take this to another application and not end up with just a bunch of white textures or whatever that a render is going to end up doing when it doesn't understand the MDL shaders. So, so what do we do? I can, we won't get into that, but I have to choose is what developers will experience, right? They'll be like, what do? I have to choose because I can't, I either have to bind this one or I have to bind this one. So since USD first released, I think there's been a solution for this. And it's not too much work. All we need to do is if we open up, I'm going to show this interactively, and then we will look at look at how to do this in code. Can I explain the difference between OmniSurface and PreviewSurface? I am not an expert on these things at all, but just very rough difference. OmniSurface is a much richer material definition. If we just look at everything that it does, it can do. It does the base color, specular, transmission, subsurface, coat, sheen, emission, so on and so forth. And so with all those different properties, you're able to create a variety of different materials, from metals to skin materials to wax. And so to get a rough idea, we have these presets that are all built with that base material. And it's just changing the properties, maybe including a texture for some of the properties to drive some of those properties. But you can see how varied these materials are from just one shader. Whereas PreviewSurface is really meant to be a bare bones PBR material. You define the diffuse, metalness, roughness, a few other things, and the idea is that these are all properties that pretty much every renderer will understand or be able to translate easily. And so the Pixar released this as kind of a baseline. Hey, we want this to be used for interchange. Materials have always been a problem for interchange, but this is a pretty solid baseline that we can use for interchange. And so when applications support USD, they will often, almost always, also support in their rendering pipeline the rendering of USD preview surface. So I hope that helps. Very long-winded. And I said I don't know anything about this, or I know very little about it. So you can imagine how much more there is probably to say about this stuff. So we have here, these outputs from this shader are connecting to MDL, displacement surface, and volume. I could take this shader for the preview surface. Let's rename it preview shader. I'm going to do this, and then we'll talk about what this is doing. And I just dragged it into the OmniSurface network underneath the material. That puts it into this network. And so now I'll just plug this one into here. And I'll plug this one into here. And so now, in real-time mode, let's focus on this one. This is the one that matters. This is the one that I want to set up one material and I want it to work everywhere. But I also want to use MDL. When I'm using RTX path tracing iRay, it's using the MDL shader. How do I know this? Because it's the red output that I chose for it. And then when I switch to Storm, which is for our simulation, this represents any other application out there that supports USD, I have this preview shader, which is just the USD preview surface, right? And that will be my fallback. So this MDL : this is what's known as this. We call it a token, and this it represents the rendered context for this material. So if for any the render is going to come and look at the materials, and if it, in the case of RTX, it's going to look for MDL, and if it finds it, then it's going to go ahead and use that to render. And if it doesn't, it will fall back and use the non-tokened properties. So, if I disconnected these, right, I didn't author any MDL outputs. I'll just do surface. We don't need to do volume because we're not even outputting any volume. If I disconnect that, now it's going to fall back to this displacement property, and it's going to use the preview surface. So that's all there is to it. Any questions? And then we'll go ahead and I messed up on that, but I don't know what it connected there. But yeah, any questions? Yeah, so Funky Boy asked, so Pixar Storm is good to see what material might look like in another program that supports USD, but maybe not MDL. Yeah, absolutely. I think that's a really great way to a quick check when you're in Omniverse, and then also. Let me connect this up. I don't know if this is going to do the right thing, but no, it didn't connect the right thing. I don't know how to. I'm going to recreate this really quick. And so what I was getting at here is, for illustration purposes, I use two distinct colors so that we could tell the difference and understand what's working where. But for the purpose of your materials, you would build out two shader graphs that look fairly similar, right? It's not going to be one-to-one. You can't do skin with preview surface shader, but you could do a nice approximation of the diffuse color at the very least, right? So you build out those two, you plug them out into the output of your material, and then the renders will do their job of picking the right one. So let's try this one more time here. All right. And we're just going to connect surface. I need to pick a color. And I need to assign this. There we go. So red, green, beautiful. Now I'm going to save this out. I'm going to save this as a USDA just in case. And we'll call this test materials save. And then we'll come over here to, I'm going to open up USD view. This is the viewer that comes when you download the USD library and build it, and we provide it from the Omniverse launcher for you. And I'm going to go ahead and open the test materials, right? And so this is the storm render. It says HydroGL, that's storm, and we get the green. So red in Omniverse, green in other application that doesn't understand, that doesn't have the RTX renderers and or doesn't know what to do with the MDL shaders. Okay. Any other questions before I jump into the code? So if you're not going to be programming this stuff, you're an artist, or you're fine doing it interactively, we don't really, I don't think we have tools to do this right now. I think the goal will be, we've talked about at GTC about MDL distillation, which would distill, you can distill the MDL into other representations. So I think there's going to be work to either automatically or on demand distill the MDL to USDPreviewSurface or any other, but USDPreviewSurface is a good candidate, right? So I could build my MDL, my fancy Omni surface, and then, I don't know, right click and distill to USDPreviewSurface, and then hopefully it would create the USD preview shader in the network, and also wire it up to the material for me, so then I don't need to do that manually. But for now, what I did here interactively is not a bad approach, and you could build up a library of materials in that way, and work that way. And keep in mind, I'm only showing color, but there's no reason why, or I'm showing simple diffuse color. There's no reason why you couldn't build this once. Open. I have no patience for this loading bar here. There's no reason why you couldn't build this once, and you have a file reader. It'd have to be the one from the, where are we? From the preview surface texture, but you could have that texture sampler, feed it into the diffuse color here, and also feed it into color here, and then and that way, if you want to repaint that texture or whatever, both shaders would get that update. Or you could have that as a template, and then you could bring in all your editing in that template is the file reference to the textures, and maybe you might have to go in there and tweak the weights on these, but it'll definitely be better in Omniverse in the future. But just to give you some ideas if you're trying to do this workflow now. Cool. So let's get into the code. So I'm going to go ahead and suppose we can delete these. And I'll delete one of these. And then I need to make sure I have my extension loaded here. There we go. Okay. So here's my VS Code. I am starting from scratch. I don't have this material code memorized yet. I don't use it often enough. But if we go here to the USD materials, there's a kit command for creating the MDL material. And then we could also do it this way. Let's do it. We said we're doing it vanilla, even though, MDL is not really going to work in a lot of contexts outside of Omniverse. We'll do it the vanilla way. Okay, so I need to get stage. So in Omniverse, I am doing this part in Omniverse. I do need to use this API for this. You can, if you're not using Omniverse, you can use Pixar USD stage and open a stage or create a new one. And I guess we can do an Omni PBR. Do Omni Surface. Let's see if this works. Okay, let's take a quick look here. So I'm going to adapt this code for Omni Surface. So if I look here at the definition for Omni Surface, I look at the shader. It is Omni Surface MDL, and the sub identifier is Omni Surface. So we'll go ahead and delete that. And everything else looks good. So we're creating the material, creating the shader prim, defining what that shader prim is and does, and where it reads its information from. And then we're connecting the output from the shader to the surface displacement and volume. So let's go ahead and save this, run it. And here we got the Omni Surface. And here's our shader. It didn't find, because I didn't update the sub identifier, I guess. Nope. Didn't know anything about that, right? There's no Omni PBR in that MDL. Makes sense. And to clear this and do it one more time. So here I deleted the scope and it replaced it with a typeless prim, and that's okay. Okay, so we have this material. It looks like the one that I would have created from the menu. And we can assign it. And it works, right? Now let's take a look at this graph again. Remember again, it's connecting to MDL prefix, displacement, surface, and volume. How did that happen? Because I gave this MDL token here. And if I remove it, then I can rerun this. If I remove it, then it's plugging into the fallback universal properties here. So this one, so that's what's going on there. So let's take a look at the API here. This is what we're doing here. We're using it in this API, and then it takes one optional argument of render context, which you could use these USD shade tokens. By default, it will use universal render context, which is just an empty string. But we can also pass in any other token, which is just essentially a string representing whatever we want to prefix it with. So if you have some custom render you can, and you have some custom shaders, you are free to define the prefix that you want to use. You may want to look at, talk with the USD community to make sure you're not conflicted with anybody else. But for example, Blender cycles, you could do cycles : and then the surface to do an output of that type. I was going to check here to see if we show the values. There's a bunch of different unrelated tokens in here. There's no mention of that. Sorry, that was just a side search for me. Okay, so we got that. Any questions on that? So we do want MDL here, right? That is our render context. Now, all we need to do is define the other nodes and plug them to do the same thing, create output, but create it to the other one, or output, connect the output to the output, the fallback one, the universal one. So we'll do same business here, but we'll do preview shader. And the path is going to be different, right? No, I guess this will be okay. And then let's take a look at the snippet for USD preview surface. So if we come over here, create a USD preview surface material, and we have, here's a basic one without any textures, right? And all I did to get here, by the way, is USD snippets. I think everybody, well, I think ranked pretty high now, so it should be pretty easy to find. It'll bring you there. We need to change that title now that I see that. But yes, it'll take you there. Cool. So we're most of the way there. I already have the imports. That's great. I don't need any of these. And we're going to create a shader by ID. And we'll just do, I think the defaults are fine for this. We just need to set this to, we'll do blue this time. And I should probably set the color for the other one. Color. Red and blue. So now come over here, delete this. No. This one, whoops. This one should have that in print. And go. Oh, that's interesting. Can I get automation on this? So in our USD portal here, we have, that should have been right. Python reference, USD data types. The type name here, vector 3F. Oops. The red color didn't work. Weird. But let's look at this and make sure that I didn't even build the material here. So this one's called diffuse reflection color. There you go. So come back over here. This is a color 3F, and this should be diffuse reflection color. And this time it should hopefully work. All right, I'll do it more explicitly here. Hopefully that'll do it. GF. So is it, oh, it's because it's an array. I think it needs to be a tuple. Try one more, and otherwise we'll explicitly use the class. There we go. Nope. So GF vec3f. And I need to import GF. Nope, really doesn't like it. Is it because it's already created? Well, it's a different error. There we go. Loading. Or crashing. Sorry. All right, I won't mess with the color right now. There's when I'm trying to do these things interactively, there's a bit of asynchronous coding going on here. And sometimes the attribute may be created, may not be created. Oh, and I messed this up. I wonder if that was causing all my troubles. What happened there? I'm I'm not going to mess with it. I don't need it. So create that sphere, and then let's go. I got to connect this. Okay. Same deal. I need to recheck this code. I thought I had tested this before. There we go. Okay, so if we get a storm, we should get nothing. Nothing. Let's take a look at what happened here. This looks correct. It's connected to preview shader outputs. This one's connected to the shader. And what is different about this? Drop this one way down there. Okay, that looks right. That looks right. I'm just going to plug in the color here. See if we can get some color. That really doesn't want to connect, does it? So I messed something up. But everything looks good to me. I don't know why that one doesn't want to wire up. Token, material. Should that be a token? Does that remove that attribute entirely? That's nice. Property. Nope. Let's save this and reopen it just as a sanity check. Oh man, I never assigned this. I should just put that in the code. All right. So if you run this, this is what happens, folks. Live coding. That's going to apply. Now when I switch to Storm, I get blue and I get white for the RTX. Okay. So if you're still with me, sorry about that. That's the gist of it. There's one more thing that I can, one more little tidbit that I can share with you. This took me a little bit of searching, but I think I found it. If you want to target Storm directly, so I'm not sure why you would do this. Sorry, I thought that looked weird. GLSL effects. If you want to target Storm directly, this is, I believe, I tested it and it seems to work. I believe this is the render context for that. So if for whatever reason you would want to have a shader for RTX, a shader for specific to just Storm, and then another one plugged in as the universal tokenless output, a render context list output, then that's how you would do it. I don't have a good reason for that off the top of my head, but I thought I would just share that. So if I do, so we'll do that now. We'll retry it. This code should still work. The MDL loading and compiling. Did I get it? There we go. If we look now at the outputs here, we have, I'm not sure why it doesn't show the prefix here, but there are the GLSL FX render contexts, and those have the connections. And then the fallback ones don't have any connections. So if I open this up, we'll go ahead and save this again. So I can switch over to Storm. I still get the blue one on that one. And just for good measure, we'll check in USD view as well. And we should find that it works as well. It's funny because the default scene that we use here is a blue sphere, but you'll be able to tell the difference in a moment. My blue sphere is all nice and smooth. So if we look at that binding here, there's the GLSL effects, and that's what's being used. All right, that is all I have to show. Anybody have any questions? All right, I got that code sorted out. I have like 8 minutes. If there aren't any questions, then I'm going to play around with this to see what I did wrong here. Fix this. I believe it's that the issue is that I used square brackets instead of the parentheses, which would be a tuple. So let's try that now. Feel free to shoot your questions while I do this. Here. And did we get our color? Yeah. So that means that this one should theoretically work too. And we'll talk about why that did or didn't work. Here we go. So now when I apply this, I should get red and blue. RTX is red, Pixar Storm is blue. Cool. There's the full example. As to why that didn't work and why I need to fix that snippet. If we look here at this data types, USD data types table, this is really handy. It will tell you, this is the value type name, this is the token, and this is the Python constructor. So for any data type, this column tells you what you need to use with SDF value type names. So when you're creating a property and you want it to be a specific type, you do SDF value type names, and then this is the name that you would use for that. Then after you've done that, so I'm using color 3F. This token is the one that shows up in here when I hover over the label. In the parentheses, it shows me the token name, color 3F in lowercase. It's also, when I edit this USDA file, it's also what will show here. So if you're ever looking at a USD file and you're like, oh, I want to recreate this. This is exactly what I need. I need to write code to create this. Well, you see here that it has this color 3F token. So that means that when you're writing your code, you come over to this table and you realize, oh, this is the token. So this is what I need to use when I'm defining the property using Python. And then the last column, the Python constructor, this one tells you what you need to, how to construct an object with the data so that you can set the value on that property. So if we look here, it would be what goes in here. And so the recommendation here was GF vector EF, and that's what I was trying. I don't remember what issue I was hitting earlier. It was because I never assigned the material or something. I don't know. But I could use that in this space and it would work. In fact, I should show that just as an I told you so to myself. No errors, right? And so now I can come over here, assign it, and I still get the red. So that's great. But alternatively, if we look at some other examples here, I do think we show, for example, for these double twos, for these vector type data types, we also show as an example that you can use a tuple with the right number of components, and that'll work. So as a general rule of thumb, if you don't want to use the GF classes, if you want to get by without that, scalars are just basically 1-to-1, except for float would be used for both double and floating point precision, single floating point precision. Vector type data types, you would use tuples, and anything that ends in array, you would use a list with the right component, with the right element type in that list. So in this case, it's a double two. So it's a combination of a list and also this double two. So super handy document. Highly recommend bookmarking this. Remember that it's here. If you're defining properties, it's really useful. So we'll end it at that. Some ending notes here. If you haven't joined our Omniverse community yet, we have this Omniverse Insider program where you can sign up. You fill out a form. You can fill out a little bit now, fill out more later. But it's just asking questions about who you are, what you do, what applications you use, so that we can better connect with you and know, what type of work you do and what opportunities we may have that may be a good fit for you, and whether that's product testing, user focus groups, job opportunities that may come along. That's what we use this for. Other than that, I shared this. I'll go ahead and share this link here. And that's it for today. I hope this was useful to you. If you have any other ideas, questions about USD that you think might make for a good Omniverse with me or code with me stream, let me know and I can take a look at it. And so I hope you have a great week. Developer Office Hour is canceled for this week because we have Friday off. So I'll be taking that day off. But other than that, I'll see you around.